Speed of efflux we are done with. Next is venturimeter. And the interesting part is you had one question directly from the venturimeter. Directly. This was first application, speed of efflux. Second application is the venturimeter. So what happened in this venturimeter? We measure the flow, the speed of the fluid. Right? So a device that measure flow speed of the fluid, incompressible fluid. Because in this whole chapter, you have to remember we use incompressible fluid. We never know if you get theoretical question you can get from the incompressible fluid. Okay, any doubt? And in this case, if you draw diagram of the venturimeter, so what will happen? You will have different height like this. And so there will be two end and a tube like this. Like this. This is the tube. And you have two area, one small area like this and one big area like this here. And these area are different. Example here, small area is A and here big area is A. Got it? If you see height uh, from a given point, so you can measure what is the total height difference. Example, if you take here and if you take almost here, the height difference from where we are measuring it is h. You should know what are the criteria while solving any question. Through this tube, fluid is moving, area is different, and you want to calculate what is the flow speed of the fluid in this case. If you have to apply Bernoulli's theorem, how you will apply Bernoulli's theorem to Hina? What is the Bernoulli theorem in this equation?
Sir, it's that like the same velocity, like velocity times area will be the same at every point.
What is Bernoulli theorem? Correct.
Uh, Wait one second. It's a streamlined flow of incompressible fluid.
Yeah, but equation.
Pressure plus kinetic energy by volume plus potential energy by volume is constant.
Very good. So this is constant. Correct. If
Yes, sir.
we write in the formula half rho v square rho gh is constant.
Yes, sir.
This is the equation.
Yes.
Mm. So what we are doing here, if this is the real equation, guys, then you know in this way you can write P1 plus half rho V1 square plus rho GH1 like this is equal to P2 plus half rho V2 square plus rho GH2. Got it? In this case, if we take pressure difference between these two points will be equal to rho GH. So you have to calculate rho gh in this situation. And if you don't consider the height and you eliminate the height, can you say your P1, because P1 and P2 difference will tell you the rho gh, this equation, difference between these two. So P1 plus half rho V1 square is equal to P2 half rho V2 square. Our main concern, as diagram indicate, is area, velocity with which it is entering into this. So if you calculate what will be the V2 velocity using the equation of continuity, Jordan, using the equation of continuity, what will be the equation, like what will be the value of V2? What is the equation of continuity, Jordan? Continuity. Jordan, are you there? Jordan, what happened? Am I audible to everyone, guys?
Yes, sir. So do you want me
Yes,
to
sir.
call him?
Yes, sir.
Yeah.
I'll call him and I'll come back one second.
So, Chandana, if this is the equation of continuity and you want to calculate V2 value, how you can calculate V2 value?
So A1 V1 divided by A2.
A2. Here A1 is A, V1 is V1, and divided by second area is small a, because we took in the same way. Correct? Using the same equation and taking the difference, P1 minus P2 will be equal to uh, half rho.
Sir, there's a
V-
cockroach in his room and his laptop shut down or something. He'll rejoin in a minute.
What
So
is
I'm
this
just
point?
killing the
Cockroach?
cockroach, sir.
Literally,
Huh? I'm not kidding, sir.
cockroach in his room, and so his mobile, his
No, no, not
laptop.
because of that. His laptop also stopped working all at the same time. He was killing the cockroach when you called him, sir.
Okay. Okay. So this will be um, V2 square minus V1 square. Make sense, guys? And I told you P1 minus P2 will be equal to rho GH equal to half rho. What will be V2 value in this case? Using the equation of continuity, A V1 divided by A whole square minus V1 square. Here, one more thing. Jo-
I'm sorry, sir. There was a little bit of issue in the room.
I explained,
What?
Jordan, you don't worry.
No, no, no. Tell me, Jordan, in detail. I
Sir,
would like.
so
Uh,
yesterday night, there's a
tell me in short. Tell me in short. Uh,
cricket entered my room. It never let me sleep, and I'm scared of it. Then now it's underneath my
Was
table.
it
Now I
playing
got it
cricket,
out.
Jordan?
It
with
jumped on
you.
my face enough.
Okay. Uh,
Yesterday night it was there, it didn't let me sleep. So I slept around 3 o'clock after like trying to push it to one corner of the room. Now it escaped and it was
okay.
underneath the table. So I was like, finally I'll get rid of it. So my uncle gave me a broomstick and all. He gave it to me and I pushed it out.
I thought you were friend as of now.
What, sir?
I thought you will be friend as of now.
Friend, why? I didn't understand.
Like you can have bond with anyone. You have communication skill.
No, sir. See, if the friend jumps on you in the middle of the night and like doesn't let you sleep, then what is the point?
Yeah. So
So can you
I
just
just
Sorry for
zoom
the
out a bit? I'll just copy what I've
it's
missed.
okay. Anurag. I'll finish this part. 1 minute.
Yes, sir. Yes.
One more thing. If you are taking pressure difference here, Anvita, did you make notes from the video yesterday?
Yes, sir. Sent it on the group.
I have to check yesterday night whatever Sara, Chandana, and Anita sent. Here you will take the average mean of the density. You will take mean of the density. That's why you will write here mean of the density. Arey, here you will write mean of the density. And if you take mean of the density equal to half rho V1, we will take outside. What will be the value? A by A whole square minus 1. So you will feel you don't need to remember anything, just applying the formula of Bernoulli theorem. And second thing, pressure difference is equal to rho gx, average density. So this is what we started from today. Venturimeter is a device that measures the flow speed of the fluid. If you apply Bernoulli's theorem, which says that pressure by kinetic energy per unit volume, potential energy per unit volume, it will be constant. In this case, we are considering the pressure difference will be responsive is equal to the rho gs, but rho average. That's why we are considering only two parts. Are is it yeah. This P1 half rho V1 square. This is pressure plus kinetic energy per unit volume. Pressure on the another side, kinetic energy per unit volume. You take P2 on the another side. P1 minus P2 is equal to this. P1 minus P2 is equal to rho GH or H rho G. But mean, and you will get the answer. So we are not bothered about the what is our formula. No, we need to just take care of Bernoulli's theorem. जुटी पड़ी है भाई बुआ तो नहीं काबू मान देंगे Done, guys. Anvita and Jordan.
Yes, yes. I took a screenshot.
Hmm. Anvita, then
Yes, sir. I wrote it.
if all of you wrote and this was the Venturi meter, NEET asked direct question ki Venturi meter is based on which theorem, I guess. Direct question there was. And recently, not like very old. I'll show you. But hmm, let me check what you did. Okay. So what are the application of this Venturi meter? Example, in Torsley law, when we measure the speed of efflux, we get what will be the speed of fluid that is coming out of the hole. Here we are measuring the speed again of the fluid. And where do we use? In the carburetor of automobiles. Have you seen carburetor of automobiles? What is the spelling? Carburetor of automobile. I'll show you in the diagram also. Has nozzle, and same nozzle is known as Venturi channel. Have you seen, guys, this?
Yes, sir. It's that part of the engine basically where the air and the fuel mixes so that it combusts to form energy.
Yes, I will show you. Carburetor of automobile with nozzle. See what is written over there. Main nozzle Venturi choke well. Got it? What will come out through this Venturi, Jordan?
Come out as in, sir?
What is the use? Why we are using this?
So for combustion, so that like the amount of energy is formed in reactions used to power the vehicle.
High speed air will flow out of this because after combustion gases will release na CO2 gas.
Yes, sir.
So that's why this will come out through this nozzle. What is the meaning of nozzle? It will allow passage of something. What is the passage? Airflow. Okay, I will show you if there's a diagram. Carburetor, main nozzle, through which air will also come out. So this is the one major application. Carburetor of the automobile have nozzle or venturi channel. What is the use of this? Air will flow out through this venturi channel at very high speed. Any doubt, guys? But my question is, कि air is flowing out with the high speed through this venturi channel. What is the use for us? Why we are reading about this? Even if we don't read this, still air will come out of this. गोलगप्पे बनाना खाते बता मम्मी
गोलगप्पे बनाने के गोलगप्पे बनाने के ये गरीब बनाए लेंदे इतने गोलगप्पे बनाओ बनाने आवे ये खिलाने हैं उसमें
Yes, guys, you got my question. My question is कि even if we don't use this venturi meter, air will still come out because combustion. And whenever there is a combustion, what will happen? Your fuel will react with the oxygen and it will release CO2 and lot of energy. CO2 means air will come out. This CO2. What is the purpose of this Venturi channel? Vandana,
Yes, sir.
what is the purpose of this? Here, pressure is reduced at lower end. And when pressure is reduced at the lower end, then petrol will be sucked up in the channel. So there will be proper supply of the petrol or diesel, whatever we use in the car, and there will be proper mixing of the air to the fuel, which is necessary for the combustion because you need oxygen in this case. Okay. So when pressure is reduced at the lower end, you will see petrol is sucked up in the channel or any fuel is sucked up in the chamber, and there will be correct mixture of air to fuel. And when we are saying air, we mean by the O2. And if you do it, there will be proper combustion. Tell me, any doubt? So you should know how in carbonator we have to supply oxygen, we have to remove CO2. There are two things. If you want to supply oxygen, you have to reduce the pressure. If you reduce the pressure, then through the suction process, oxygen will go up with the this with the fuel, proper mixing of oxygen with the fuel and burning. Because remember, for burning, you need to supply proper oxygen to the fuel. Anybody have doubt? Anybody have doubt, guys?
No, sir.
If
No, so can you
not,
scroll a little bit up?
if not, then same process we use for many things. Example, in the filter pump or aspirator, we use the same process. Through the suction process, there will be supply of the material. Bunsen burner, you must have seen in your lab. Every lab have this Bunsen burner. You have atomizer and you have sprayer. You must have read in the 11th class for sure, at least this sprayer for the like in case of perfume. So what happen when you press below, then your material will come up. You are changing pressure, and due to the difference in the pressure, your material is coming up. Yes or no? Anybody have doubt? Even same thing happen in the insecticidal spray. When farmer spray, they use the same pressure. They will press below. When they press below, like how we do with the. Not only this, I'll give you the simplest example. You must be using this hand wash. What do you do to get the hand wash content out? You press it and it will come up. Exactly, this is the application of Venturi meter and Bernoulli. Understood, guys? Look easy now. You can finish your portion because very high chance ki from here they will ask the theoretical question, and they already asked theoretical question in NEET.
मेरा साथ में खड़ा है वाला इच्छा था ना मेरा साथ मंदा को देखा पूरा हो देख अरे सर उधर दरिया एंट्री लोग आई
इन्ना जी रात ने भेजा नहीं इतनी ज्यादा सही हुआ है।
सामने भेज दूंगा इसमें को लगदा लाइट लाइट चाहिए
Then guys,
Yes,
साइड दे
sir.
दो सामने पे हो यार तू है जी मेरा
if you are done, then check
दो
which
का करा काम ये छोड़े लेते
if you are done with it, we can move to the other part, and this is pure biology. Next part, blood flow and heart attack. We are doing the application of Bernoulli's theorem. We did Torricelli law, speed of efflux. We did Venturi meter. Third is the blood flow and heart attack. Blood heart attack. So why heart attack happen during the blood flow process, and what is the role? Example, if there is a plaque accumulation in the blood vessel, Barinder, what is the name of this condition where plaque accumulation in the blood vessel? This is given in our NCRT, in our NEET syllabus. Atherosclerosis. Atherosclerosis. So in case of atherosclerosis, plaque will accumulate in blood vessel. So when this plaque deposit in the blood vessel, then blood vessel will be constricted due to the accumulation of plaque. In this case, what will happen? There will be more demand of the blood from the heart side. In this case, what will happen? Your BP will be increased, blood pressure will be increased to compensate this. And if you increase the blood pressure, pressure inside will decrease. Pressure inside will decrease. And if pressure inside decrease, what will happen? There is a chances of collapse due to the external high pressure. Any doubt? So remember, we have two concepts of the Bernoulli's theorem. One, pressure is inversely proportional to the speed. This is the speed. This is pressure. Okay. So what happens if you increase pressure, speed will decrease. If you decrease pressure, speed will increase. And second thing, if one pressure is increased, like outside pressure increase, then inside pressure will decrease. These are the two major concepts you need to understand for the Bernoulli's application. Pressure is inversely proportional to the speed. And second, outside pressure, if it increase, inside pressure will decrease. Example in this case, outside blood pressure increase, inside blood pressure will decrease, and it will lead to the collapse, heart attack. Any doubt, guys? Whenever there is a high pressure, less velocity. Less pressure, high velocity. This is the most important application. Why? Because in your Bernoulli theorem, you have pressure plus half rho v square plus rho gh is constant. Okay. So if you take velocity on the another side, then you know pressure will be equal to velocity go to another side, it will become minus half rho v square minus sign. It means when you increase pressure, your overall value will increase, but in negative. That's why your velocity decrease. Make sense, guys? Application of the Bernoulli theorem only. Reason negative side. Any doubt? Guys, is it getting too much or you are able to correlate?
Sir, right time was I feel like you're going a bit too fast.
It's okay if you are able to understand and you are not able to write it completely. In the end, I will send you PDF. You can note down. You can leave space, whatever you miss. Make sure you should understand. So, what happened? Then, fourth application is the dynamic lift. In case of dynamic lift, we will discuss about the same thing. There will be velocity difference. And whenever there is a velocity difference, then it will lead to the pressure difference. Okay. If there is a velocity difference, there will lead to the pressure difference also. And due to this pressure difference, example you will see ki ball is spinning. If you take the example of ball, then ball will spin. And this effect of the dynamic lift in case of ball is spinning is known as Magnus effect. Have you heard about this? Example, if you take this ball, so what will happen if air above and below is exactly same? Example 1, 2, 3. 1, 2, 3. So if it is exactly same above and below, you will see there is no spinning of the ball. Ball will move straight because total air pressure above and below is same. The velocity will be same. But in second situation, if ball is spinning like this, so what will happen if example you have more air above because of the speed and less air below? Understood? So if you consider this spinning ball, in this case, velocity above the ball will be more compared to the velocity below the ball. Here velocity is more, here velocity is less. If velocity is more, pressure will be less, below pressure will be more. And if lower pressure is more, ball will spin. Any doubt, guys? And we are applying the same concept. Whenever pressure increase, velocity decrease. Velocity decrease, pressure increase. Okay. And same dynamic lift happen in case of wing. Same dynamic thing happen in the case of wing. Ki if you have wing, this is plane. Below, you will see more pressure. Below, you have more pressure. And above, you have less pressure. So ultimately, what will happen? Lower pressure is more than the upper pressure. It will move upward. If you have plane, aeroplane wing. So basically, you increase the volume of the wing, and based on that, you can control the pressure, and that will decide how plane will move. Got it? And this streamline flow is done. So what we covered in this streamline flow, this is important to summarize. See, streamline flow, hydrodynamic, how air or water move, because we are talking about fluid, and both liquid and gases are considered the fluid. Steady flow, all the particle flow in the same direction with the same speed, and when they are passing through a given point, their speed will be same. Equation of continuity, a1 v1 is equal to a2 v2. Area into velocity will remain constant. Critical speed, speed beyond which flow will be turbulent, and below which flow will be steady. Bernoulli's principle, based on the law of conservation of energy, based on the law of conservation of energy. बुआ फोन आ रहा तेरा. Okay. Then speed of efflux, where we apply same Bernoulli's theorem, and it is known as Torsi's law, and we calculate what is the speed with which fluid is coming out of the container. Venturimeter, where we use what is the speed of the air flowing out, in the example in case of carburetor. And next, blood flow, like if there is a plague, there is a blocking of the blood vessel, then outside pressure will be more, inside pressure will be less, and there is a chances of collapse. And dynamic lift, in the dynamic lift, what will happen? You will see ki aeroplane wing will be managed in such a way ki it can lift accordingly, and whenever you want to reduce pressure, you will reduce the area, so it can come below down.
So just 1 minute, I'll copy it.
Hmm. And this topic is done. Now we will start viscosity. हेलो राम राम भाई साहब, और सुनाओ। हाँ हाँ हाँ। ब्याह में सारा लागे के रह गए। ये बात करें, हम ब्याह में सारा लागे के रह गए। हम्म। हाँ, ब्याह में तो इतने इतने खर्चे। आपने मेरे सारी चीजें का जवाब तो कौन दिंदा। मैं ये कहूँ, ब्याह का टाइम में इन चीजों का नहीं
लंच।
लग सकता। समझ गया, लेकिन उनमें पहले इतने खर्चे हो रहे तो इसमें नहीं। नहीं, वो तो मैं समझ गया, कोई बात नहीं, लेकिन इस टाइम तो खुद ले समझ गया, लेकिन इस टाइम थोड़ा सा भाई साहब नहीं हो सकता समझे तो। ठीक। एवरीबडी इज डन।
Yes, sir.
I let me show you guys the PDF mechanical property. They were solid and fluid together mechanical properties. See, 2023 question. When meter work on the
Bernoulli's principle.
exactly. So that's why I'm telling you, whenever there is difficult topic, you can always assume कि they will ask the easy question. Here, if, whether you take roof, if roof is moving away, then lower pressure will be high, upper pressure will be low, and this roof can fly off from the house. Correct? Example again, theoretical question: a fluid is streamline flow across the horizontal pipe of the variable area. Area is different, so velocity will be different. For this, which of the following statement is correct? Complete application of equation of continuity. So if velocity is minimum, it will be the widest part. If velocity is maximum, it will be the narrowest part. So velocity is minimum at narrowest part is wrong. Velocity is maximum at narrowest part is correct. And widest part, velocity will be minimum, pressure will be maximum. Make sense? Are you getting? So the reason we spend almost an hour and there are only 1, 2, 3, 4 questions from this topic. Streamline flow, one question. And now viscosity from 11, you have good amount of questions, like 7 questions, I guess. So viscosity we can cover in half an hour. And then surface tension, again maximum number of questions. Surface tension will take half an hour. So within an hour, we can finish the full topic. Okay. So give me a minute. All of you are there?
Yes, sir.
Yes, sir.
Topic name is viscosity. And you already know about viscosity. Anvita, what is viscosity?
या तो क्लास कर ले अनसिटी
Anvita, what is viscosity?
So, something friction in something you told yesterday in yesterday's class, right?
Yes, friction in fluid.
Friction fluids.
Fluid, yeah.
Friction in fluids, and it exists between the two layers. Exists between two layer of fluid. Correct? Fluid. So what happen when you have two different layer? Then there will be top surface and fixed surface. At top surface, you will have maximum speed of fluid movement. Maximum speed.
तेरा नंबर किसे पढ़ते हैं
हाँ बिल्कुल बढ़ जाएंगे. हाँ ये तो मनने ज्यादा जरूरत है ज्यादा.
बोल भर है मेरा रिया कौन सी बात कही है
हाँ नहीं सच में मैं मजाक नहीं कर रहा भाई.
मन
कितना देना कौन चाहता.
आज जरूरत है और पीस तो है मेरा खाता में
हाँ सरीस भी ले लेना.
कौन सी उसकी
सरीस
क्या था
उसका माँ का खास मित्र भी है तेरा और इतना तो खुद देगा.
ना ना मतलब है छोड़ मित्र हो लिया बेईमान निकले
कुकर
कुकर ले बिल मतलब 1080 रुपये देगा है था मिला बिल को नहीं भरिया तो नहीं भरता जो मेरा भी गिरा था इसमें
करना दे दिए थे.
हाँ बस उस दिन पास घर के तो बोल पड़े मैं तो तुक्के नहीं करता ये मैं इस गला था भरते हुए मेरा
रमेश गिला ठीक था. हाँ और ठीक बंदा है. So guys, have you seen in case of canal when water is moving, then near the boundary you will see fluid look almost static, but at the middle of the canal it will नहीं हो सकता. देखो
मैं पहली बात तो बता दूं और जब मैं उस बात पर आया था मैं वहां पे ले आऊंगा
अरे तो फिर मैं कहूँ भी ब्याह अगर मैं नहीं मांगेगा
2 दिन खातर चाहिए मन कौन ज्यादा लोड है पागल हूं मैं
मैं
जाए
तो एक एक रुपया भी ठहका ब्याह करना पड़ा नहीं हो तो मेरा उरे इतनी बड़ी चीज
तो पैसा का जवाब तो नहीं है
ना जवाब तो कोई नहीं लेकिन अपना भी तो चीज भी तो लग गया ही वो.
है
उसमें भी खर्चा लग गया और फिर उसके बाद ब्याह में भी खर्चा. तो
मतलब 2 दिन खातर चाहिए पर जरूरी है ना इसलिए आना पड़ता है
चाहिए तो है लेकिन इस टाइम को नहीं कर जो ये टाल को निकलना मैं लेकिन मजबूरी है मेरी.
मैं तो टाल क्यों नहीं करता
जहाँ तो पहला भी तो अपन लेने देने का करते टाल को
फिर की
निकल
बात है
जो बट इस टाइम को नहीं हो सकता. इस टाइम को नहीं हो सकता हमने कर जरूरी तो थे लेकिन नहीं हो सकते. मम्मी चाह तो बना दे
ना
क्या ना
रोटी खा गया
ना मम्मी चाह कोई नहीं.
ओके वो पैर भी घस रहे मेरे तो घर में
पैर धो ले बाहर.
हाँ ये था सीधा
और क्या ठंडे तो ही रहे हैं. हाँ यस गाइस. So have you seen example if you take a canal in the middle you will see the maximum speed of water. You can feel it कि there are particles moving in the middle V max, but along the line of this canal you will see कि water look static. It means almost zero. Have you observed this same thing happen in the pipe? In the middle of the pipe, you will see the fast flow of the water. ना उसका थोड़ी दिक्कत सी हो रही थी तो अंदर हाँ तो but along the surface of the pipe velocity will be minimum and zero. It will look static. Okay, so due to this situation you will feel कि upper layer pull forward and lower layer pull backward. Upper layer pull forward and lower layer pull backward. And because of this, that this type of flow is known as laminar flow. Any doubt? Okay. So, if you calculate the viscous force between the two layers, Pratigya, what are the factor in your opinion? It should depend upon the Pratigya. What are the factor on which this viscous force will depend on? Huh?
कुछ याद नहीं है.
कुछ याद नहीं है. चंदना? Force directly depend upon the area. Force depend upon what is the speed with the given situation. This is known as velocity gradient. And this is area.
So it also depends on pressure and temperature.
Pressure will impact, temperature will impact, but if you look at this, temperature will affect the friction. So
Friction. Okay, not the
friction,
force.
not the force. Frictional
Okay,
amount, that
Hmm.
is the nature of material, that will talk about the coefficient of viscosity, that will be affected by the
So then what can we say about
temperature.
density of the fluid itself?
Density of the fluid. Density of the fluid, yes, it does. That's why in case of density, what do you have? Area, length, volume, and
Yes,
that's why
sir.
speed matter. If there is more speed, more viscous force. So Hina, tell me why you have this negative neta.
Negative?
Neta. This
Because it opposes the flow.
yes, because it opposes coefficient of viscosity. Viscosity. So it opposes the change. Example, when fluid is moving, so this viscous force will always oppose the change. Same way like how friction act opposite to the real force. Remember, this F is not force, it is viscous force which is opposite in nature. That's why neta is explained by the nature of material, temperature, and all these factors. Okay, it depends upon the areas. So if you have more area, more viscous force, less area, less viscous force. Area of contact, remember, not overall area, area of contact. I will mention this. area of contact. If you have this, how many of you are Chandana? Tell me what will be the dimension formula of meter?
Sir, eta?
Yeah. Is it?
Yes, sir.
Reason why I ask this, because this is very popular question from your unit and dimension. Pratigya, you recently finished your unit and dimension. Did you see questions from the coefficient of
Yeah, sir.
viscosity? Many questions
हाँ
from
sir.
coefficient of viscosity.
हाँ sir.
That's the reason I am giving more priority, even more than the unit. No doubt unit is important, but more than the unit, trust me, it is dimension formula of this is extremely important. Like there are few dimension formula they always ask. They ask either from this gravitational constant, this work and force. If you know these four and the basic one is more than enough. Right, Pratigya? Gravitation constant,
Yes sir.
this constant, force and work. Okay, so highlight this is the very important concept, very important dimension unit. If you are done with it, what will be the SI unit, Jordan, for viscosity?
I don't remember, sir.
Poison. Right? SI unit. If you understood this well, okay, by the way, I will also draw one diagram to explain it to you. Example, you have one fixed surface above, another fixed surface below, and you want to calculate what is your speed. Okay, so you will see in the middle, you will have maximum speed, and other side, it will keep on decreasing. I'm just showing you example. It keep on decreasing. So it is showing that the middle speed is maximum, and here it will be speed will be minimum or almost zero. And this question can be asked in your exam. Next is the direct formula.
Sir, don't scroll, sir, 1 second. Just the last part, sir, the SI unit part.
Extremely important Poisson unit.
Is the symbol PI?
PL.
PL. Yes, sir. Done, sir.
We will make it lightly L, PL. So next is the Stokes law. Stokes law is easy and NEET asks 2-3 questions from the
Sir,
Stokes. Yes, Pratigya.
sir, I have some work in bank, so I will go.
Okay, sure. So
Sir.
now, guys, you will understand how it is correlated. When we talk about the viscous force in the fluid, so this viscous force is the viscosity in the simplest way, in the form of force between the different layers. So what are the factors it will depend upon? It will depend upon the nature of fluid, neta. It will depend upon the area of the uh, uh, what what should I say? Area of the body, that is radius. Radius will give you area, correct? It will depend upon the with what speed body is falling, velocity, radius, and this is viscosity, nature of the material. What we are trying to say is you drop a ball from the height. This is the fluid. This is the fluid. In this fluid, you will see that one body is falling toward this fluid. How much upward force, viscous or drag force, will be applied on the body in the upward direction? Okay, so this force depend upon the nature of the fluid, viscosity of the fluid. Remember, viscosity of fluid, not the ball. It depend upon the radius of the ball, correct? And it depend upon the velocity of the ball, correct? This is the ball. Buoyant force, upward force. So what are the factors that will decide the viscous or drag force in the upward direction? Three factors: nature of the fluid, size of the body, radius, and speed of the body. Example, if it fall with the high speed, viscous drag force will be less. Correct, Jordan?
Yes, sir.
No, ulta. If body fall with the high speed, there will be more viscous force because more upward force will be felt.
Okay, yes, I understood now.
No, because it directly depend upon the speed. More speed, more force,
More viscous force.
more viscous force. So when you combine all these three factors, you will come to know that there will be constant 6 pi neta r v. Done. That's all. That is what required. That is Stokes law. So Hina, I didn't ask Anvita question. Anvita, if this is the force, what will be your power?
So before that,
Right?
can you please go a little bit up?
This one. So Anvita, if you want to calculate power in this case, first tell me why we should calculate the power. Because in NEET 2018, question was asked from the power. Cool.
I'm not sure.
Rate of production of heat. It will tell with what rate heat will be produced. More heat production, more power. And power is equal to force into velocity. Here force is equal to 6 pi n rv multiply by v, it will become v square. Extremely important because your NEET 2018 question. Let me show you this question. Surface tension 2000. See. A small sphere of radius r fall from the rest in a viscous fluid. Again, sphere ball fall from the rest. Initial velocity 0. As a result, heat is produced due to the viscous force. In the upward direction, there will be heat. But rate of the production of heat means power. When sphere attain the terminal velocity is proportional to the. For this, you need to know what is the terminal velocity. Okay, and let's do last topic of this viscosity part, terminal velocity. But you have to apply same formula. See, in this case, power directly depend upon the v square, and through terminal velocity, you need to know what will be the v square value in the form of radius. Correct? Because v square into r, because r is also there. You will see your terminal velocity directly depend upon the r square. We will discuss this. Your terminal velocity directly depend upon r square. So v square will directly depend upon r4. What will be the power value? R4 because of the velocity square multiply by r. Can you say your power will directly depend upon r raised to power 5? See, do you have the same question? Yes. D. How do we know? We just need to know that power is equal to, power is directly proportional to v square and r. And v square, how it depend upon the r, will discuss in the terminal velocity, and then you'll get to know, okay, this is easy. Because here you don't need to apply many formulas, just simple Bion force. So last topic of this viscosity. Terminal velocity. Chandana, what do you mean by terminal velocity? Chandana, what do you mean by terminal velocity? Chandana, are you there? He is not. Barinder, what is terminal velocity? Definition wise. Barinder. Nobody is there, guys, or I am not audible.
No, sir. Audible.
You can hear
Yes,
us.
sir.
Okay, so Barinder, what is terminal velocity?
सर याद नहीं है.
ठीक है.
So constant velocity.
Constant velocity, but constant velocity what? This
Like
is correct.
after it reaches, after
When a body,
accelerating for a while, it reaches a constant velocity, right? Like when something falls from a building, first it will go really fast, and then at one point it'll reach like a velocity where it doesn't increase after that. The acceleration becomes zero and velocity becomes like
Yes,
constant.
exactly. Example, if you fall from the building in water, remember, here we are talking about the viscous force. So viscous force act in the fluid. If you fall in water, what will happen? Initially, you are falling down, and in downward direction, there will be gravity, and in upward direction there will be role of the fluid. It will try to push you upward, and downward gravity. There will be some situation like initially you are falling down with some speed will reduce. Example, this is the body, so it is falling down, speed will reduce. At one point this speed will become constant, fix. It is falling down with the constant speed, and that constant speed where acceleration is zero is known as terminal velocity. Correct? It means upward force and downward force will be same. That's why there is no net acceleration. Make sense, guys? Make sense? Example, the moment body is falling down, maybe gravity force is more, but as it keep going down, there will be the viscous force. So net force will be zero, and that's why you have the role of the terminal velocity. In this case, you have two things. You have body. This ball is your body, and let's assume ki density of this body is rho, density of the body. Second, you have fluid. Fluid also have density, and we are considering the density of fluid is sigma. It's your choice. You can assume anything. Okay, it's your choice. You can assume anything. So you have body density and you have fluid density. In this situation, what is happening? Upward force is viscous force and downward force is gravity mg. This will be viscous force, and both force will be equal. That's why net is zero. Net force is zero, so velocity is constant. Force will be zero because acceleration becomes zero. So that's what we are saying. Your net viscous force 6 pi nRV. Net viscous force will be equal to uh, this is the force. And how to calculate force in this case? Force is equal to mg. Mass is equal to density into volume into g. Correct? And density is different for the body and fluid. Volume, you know the method is the 4 by 3 pi r cube. So what will happen in this case? 4 by 3 pi r cube. This is the volume. Density is different. Body density is more. That's why density of the body minus density of fluid. And g gravity. Tell me guys, any doubt?
Sir, now can you hear me?
Yes, Chandana. Okay. Reason why? Because in this case, your viscous force will be equal to, in downward direction there will be weight of the body, and upward direction there will be buoyant force. Any doubt, guys? This is, remember, for the body, and this is for the. And now you can calculate V value, because 1R can be cancelled. Just focus only on this. You can calculate your terminal velocity. Last year when I taught the same topic, I just focus on one point. Don't try to memorize the formula of terminal velocity. You will be confused. Just focus कि upward force, viscous force or frictional force in this case will be equal to weight in the downward direction minus buoyant force upward, and net downward will be equal to net upward. Net upward is viscous force, net downward is weight minus buoyant force. Anybody have doubt? Don't focus on what you are writing, focus on what you are listening, and do you have any doubt in the understanding of. I didn't write this, na? Yeah, Stokes law I wrote. So I will write the formula because need ask question from the this. How? One R will be cancelled. If you calculate the velocity, 4 by 3 pi r square. Why r square? Because one r is cancelled with r cube. Divide by 6 pi neta. Yeah. And then okay, pi cancel. 2 2 is 4, 2 3 is 9. So your final terminal velocity will be equal to V is equal to tell me guys, any doubt? So I told you in the question here velocity is directly proportional to r square. So velocity square will directly depend upon r4 and see what we did in this question. Your power directly depend upon v square into r. So v square means r4 multiplied by r. So it will be r5. Was this question easy and direct? But many people face difficulty in the same question. Okay. And terminal velocity is done. Your viscosity part is completely done. Let me show you questions from the viscosity part.
Wait, can you go back 1 second?
Yes,
Yeah,
actually, can you show the notes? So actually, can you share the PDF now once?
no, I'll show you first question, two question. Key, this
No, no,
topic question are not
So the
difficult.
last part, 1 second.
Last part, which one?
Sure, only sorry. Don't change in 1 second. I'll take screenshots. Sir. Yes, sir, you can change.
Everybody is done. Anybody who left?
so you can change it. So.
Everybody is done, guys.
No, sir. One sir. Done, sir.
If everybody is done, look at this question. 11th. Viscous force, the viscous drag acting on a metal sphere on a diameter. You have diameter, you can calculate radius. Falling through a fluid of viscosity Pascal second. Okay. Velocity is this equal to? What will be the answer? Done. This is the formula. I told you that whenever there is a difficult topic, you will always expect the easiest question. Eta value 0.8, 8 by 10. R value half of this. So 1 by 2 mm. Mm means 10 raised to power minus 3. What is the velocity value? 2. So this is minus 4. So 48 pi into 10 raised to power minus 4. Then 150 into 10 raised to power minus 4. So if you are calculating in 1.5 into 10 raised to power minus 2 or 15 into 10 raised to power this. Tell me guys, was it directly formula based question? Force is equal to 6 pi nRV? Stokes law?
Yes, sir.
Done. So see, you can write here. Direct formula based question. 6 pi nRV. So next question guys. Terminal velocity.
So once again, previous question.
Hello. 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 हाँ जी बढ़िया क्या हुआ मगर आज देव नहीं गया ना ठीक है तो मैं बता दूंगा जिस टाइम मैं निकलूंगा कि उसी टाइम निकल जाएगा मतलब मैं आधा घंटा 1 घंटा पहले बता दूंगा हाँ नरवाना से मतलब मैं जाऊंगा तो बस में जाऊंगा तो चित्रम मोड़ उतना ही दूर है ठीक है नहीं नहीं मैं ही चित्रम मोड़ उतर जाऊंगा तो क्या दिक्कत है हाँ उठाओ imagine guys this question is also exactly same force is equal to 6 pi nRV 6 pi 3 something. What is the neta value? 0.9. Everything is the unit. Yes. What is r value? Radius 5 into 10 raised to power minus 3. Velocity 10 meter, 10 centimeter. If you convert into this 10 raised to power minus 1. When you convert into meter. Correct. Hello. हाँ जी. हाँ. Get your answer guys. हाँ. See. क्यों उनकी प्राप्त
So option B.
Yes, guys. Got your answer?
Yes,
Yes.
sir.
What
Again, explain.
answer will be from B or C, I guess, because 9 nines are 81. So around
Yes, sir.
80, 81 into 10 raised to power minus 4. So 8.4 into 10 raised to power minus 3. The answer will be B.
Yes, sir, and I got the same answer.
Yes, sir.
Tell me, guys, from this topic, you are getting straightforward F is equal to 6 pi nRV. And through this question, you can easily recall the formula force is equal to 6 pi nRV. Anybody have doubt, Anvita?
No, sir.
Question number 13. Spherical ball is dropped along a column in the highly viscous liquid. Curve of the graph represents एक मिनट speed of the ball and the function of time. हम्म
दादा फोन कर ली शास्त्री इधर है।
करेंगे पहले ही ना मिल जाए 10 मिनट बाद कुछ नहीं अंदर
तो टॉट के खड़े हो गए।
you can draw the same graph. You can draw the same graph in the terminal velocity topic also because you know initially your speed will be there and it will become constant ultimately. It will become constant ultimately because terminal velocity will become constant. So if it become constant ultimately, what will happen? B A is the answer and B capital B is the graph. Okay, so you can draw same thing here also whenever you are talking about the terminal velocity. If you are making graph, time, velocity, with the time start initially velocity will increase, but ultimately it will become straight flat. Why? Terminal velocity. Here you have terminal velocity which is constant. Make sense, guys? Terminal velocity. Tell me, guys, are the question from this topic really difficult? We are left with only one topic, surface tension. So I am sending you this PDF. We'll take 15-minute break and I'll finish surface tension. I started around 10:30 now. It's 10 o'clock. Yeah, I'll take 15-minute break and I'll finish this. And I will also send this PDF. This PDF also. So you have to see all the question from this topic. We'll discuss all the question, don't worry. It's just key here we are getting idea.
Yes, sir. 13th का answer, what is it, sir?
13th
Option A,
answer
no,
is
sir.
option A,
Yes, sir.
B graph. Okay. So 15-minute break and then we'll finish the surface tension. Only one topic left.
Yes, sir.
As of now, it look easy. Do you feel, guys, ki when we are doing theory, na, you feel like, oh, you might get difficult question. The
Sir?
moment you solve question, you feel like it's direct, straightforward formula-based question. Anytime, not only here.
Yes, sir.
Okay, before finishing the surface tension, we'll do one number known as the Reynolds number. And what is the significance of this number? This is a pure number, no unit, no dimension, which tell us what is the nature of flow of liquid through a pipe. Explain nature of flow of liquid, nature of flow of liquid through a pipe. Okay. This we are representing Reynolds number, N number and R means Reynolds. So this Reynolds number tell us what is the inertial force per unit area and viscous force per unit area. Inertial force per unit area divided by viscous force per unit area. Okay. This will be equal to V square rho divided by N V d. D means distance. You know dy d. That is what d is. And finally it is equal to V cancel V rho d by meter. Done. So nobody will ask you formula most of time. It's just what is the significance of this number. This is what most important is. This number will tell you everything. Example, if number is below 2000, then you will say that this is streamline flow or laminar flow. If your NR is less than 2000, you will call it as streamline or laminar flow. Because slow speed, so it is laminar flow. If it is between 2000 to 3000, NR lie between greater than 2000 and less than 3000. In this case, flow of liquid. हेलो, बहुत बढ़िया जी, आपने सुनाओ सोनू सिंह। काम तो उधर नहीं बढ़ गया था, ये तो बस उधर या ध्यान में कर रहा। हेलो, हाँ जी, महा काम तो उस दिन नहीं बढ़ गया था, उस दिन का दरिया बस ध्यान में कर रहा। चाली आई है अपना ते मतलब। हेलो, हाँ जी, चाली अपना तो जारी है। पूछो पूछो, मैं बताऊँ नहीं, मैं चाली तक पहुंचाई को नहीं। आज किसने दी है? फिर उन्होंने तो दे रखी थी उन्होंने, जद की हमने उन्होंने तो दे रखी थी। हाँ, लेकिन एक बार देख लेंगे कि 40 जो उनके ताई है तो उन पर तो भी आप ले लेंगे जितने दिन उन्होंने रखी है। ठीक है, मैं जरूर वो कर दूंगा। सही याद दुआ दिया, यो ग्राइंडर वाला तो मैं इबो देगा जाऊँ थोड़ी सी में। ठीक है जी। हाँ, मैं इबो जो आऊंगा दुकान में जो कंफर्म करके आऊंगा। कितने हैं उसके एक दिन के? नहीं, एक दिन के कितने हैं? एक दिन के 10 रुपये, ठीक है। Yes, guys. So if your Renault number is less than 2000, it is proper streamline and laminar flow. If it is more than 2000, less than 3000, in this case, flow of liquid is unstable and it is changing to the streamline to turbulent, like in between. If it is more than 3000, then it will be proper turbulent flow. It means between 2000 to 3000 it is changing, so it is unstable. You can't say exact one thing. So it could be streamline, it could be turbulent, it could be streamline, it could be turbulent. Understood? It can change one into other. That's all. The null number was enough. So it explains the nature of flow. If it is less than 2000, streamline or laminar, more than 3000, it is turbulent flow. Got it, guys? Got it?
Yes, sir.
Huh. So now we come to the main topic and last topic of this chapter, surface tension. Surface tension. In the surface tension, Jordan, what do you mean by surface tension?
So, I forgot the definition. So, I know what the phenomenon is, but I forgot the definition.
What no, what do you mean by like related to this? Tension that is related to only liquid,
The liquid on the upper layer of this, only upper
correct?
layer of the liquid.
So it is the force, that force acquired to have the minimum surface area.
Surface tension also makes them form droplets. That is what gives it this
Yeah.
very round shape.
To acquire minimum surface area. And to get this surface, you need some additional energy. That is the surface energy. So related to surface tension, you have surface energy. And you know energy and force relationship. Example, energy is equal to force into displacement. You will consider this only. Correct? So if you take a container, like this is the container, and you have lot of like billions of molecule in this, you have one molecule, any one molecule of water. In this case, you know it is attracted by all these sides. So net will be 0. Correct? Makes sense? It is attracted by all these sides, so net is 0 because it is related with the attraction. It is related with the attraction. But if you have molecule on the surface, so when you talk about surface energy on the surface, so what is happening? Example, you take this molecule. Here, you will feel more movement of this molecule in the downward direction because there is no net upward force. Make sense, guys? Okay. So here you will see lot of attraction in the downward direction. And when you when you attract more, in this case, it will result in the negative potential energy, means minimum energy. In this case, you will have negative potential energy, minimum energy, because anything that is stable have less energy, correct? Because here you can see only lower half side is surrounded by liquid molecule, only that will try to attract this, correct? So in this case, what will happen, less or negative potential energy, there will be the least surface area. And that's what we said in case of surface tension, it want to acquire minimum surface area. How? Because in downward force, another molecule are attracting. Make sense, guys? Any doubt? Any doubt?
No,
This
No,
sir.
sir.
surface tension is only because of the water molecule present in the lower layer, because in upper layer there is nothing, only air. And this phenomena exists only in liquid, not in air. Okay. If you understand this well, by using this we can calculate surface tension and surface energy. Example, you have any film and length of this film is L, and there is some force existing on this, like here force, this force in the all the direction, correct? F force. Now if you try to stretch it out, this is the equilibrium condition, there is no net movement. Equilibrium means net movement is zero, net force is zero. Outward and inward direction, net force is zero. Using the same situation, you take another example where length is L, and if this layer stretch out, remember this is not equilibrium, if it stretch out, then this diameter or distance travel is d, and there is more force on one side. In this situation, you can see this force will be slightly more, and here it will be less. That's why no net movement toward the outer direction. So what will be work done in this case, guys? Because there is a displacement, what will be the work done in this situation, Tuhina?
Sir, I'm not sure.
Force into displacement. That is what work done is.
Okay, sir.
Make sense?
Yes, sir.
Any doubt?
No doubt,
So
sir.
if the surface of the film is S per unit area, like you take total area as S, and film has two sides, it means you have two surface. Correct? Surface area, surface energy, and all these terms are really important. Uh, which symbol do you use, Jordan, in for your surface tension?
I don't remember.
You don't remember? Is it T? Surface tension. T. Force acting
T
per
for
unit length.
tension, T for tension only, yes, sir.
Yes, surface tension. Force acting per unit length. Chandana, can you hear me?
Yes, sir.
So, surface tension is equal to force acting per unit length. Okay. Here we will use a symbol S, and that is also tell us about the magnitude of surface tension. The reason why I am telling both of this, because if you are reading your notes, you might get the different values. Remember this. You might get different values. And different value in the sense different symbol. So you will get confused, ki, sir, which one we should use. It's your choice. You can use anything. It's your choice. You can use anything. So whether tension, uh, surface tension you are representing with T or surface tension you are representing with S doesn't make any difference. Understood, guys? Why? Because in many book I have seen T as the surface tension symbol. In other book there is S. I hope like Jordan and Tuhina, you are done with this, right? In your coaching,
Yes, sir.
which symbol they use
For what, sir?
for surface tension?
T only.
T, I think, or tau, I'm not sure.
T on. Yeah, because I've seen in many coaching institute. Anvita, you didn't attend surface tension class in Allen, right?
Yes, sir.
Huh. So it's your choice, whatever you want to use. Example, if you want to use the T, then this is the surface tension magnitude. You can completely eliminate this. But remember, different type of symbol can be given in different books. So don't confuse yourself. This tension we know is the force per unit length. But if you take in the form of this, in the form of surface energy, it will be surface energy per unit area. That is also surface tension. Surface energy per unit area, and S is surface energy. These are the basic formula, but you should know this. Got it? So, if this is the situation, tell me what will be the surface energy? Surface tension multiplied by area. Yes or no, guys? Surface tension multiplied by area will be your surface energy.
Yes, sir.
Yes or no? Yes.
Yes, sir.
In this situation, remember we are considering two surface, both sides. So consider two surface. If you consider two surface, can you say this only? So can you say in this case, if you consider the two surface, there will be surface tension multiply by 2. What is the area? Length into width, d into L. Because here we took this change d and this length L.
Sir,
Yes
what
or
is
no?
Dr. Reynolds number?
You were not there in roll number, Chandana.
Sir, I was there up to Reynolds number.
Okay. You are asking what I did up after roll number.
Yes, sir.
We were doing surface tension. Surface tension is kind of force that try to acquire the minimum surface area in the fluid. Okay. So related to this, we have surface energy. When surface tension is acting, it will try to acquire the minimum area. Minimum area means negative potential energy and negative overall surface energy. After this, we did if you take a film and it is in equilibrium, so outer force, internal force will be same, net force will be 0. There is no movement. But in case if there is proper force and responsible for some displacement, so surface tension is equal to force per unit length. Surface tension is equal to force per unit length, and surface tension is also equal to surface area, surface energy per unit area. Okay.
Yes.
So, because ultimately, what is SE, surface energy? What is the natural formula of any energy? Force into displacement. Correct.
Yes.
So force can be equal to surface tension into length. Surface energy, instead of force, you can write tension into length. And what is the displacement? T. See, makes sense, guys? Instead of force, you have surface tension into length, and D is T. But when you are expanding, you will consider two surfaces that is extremely important for your calculation part, because you will miss this. Trust me. You will never face issue in the formula of the surface tension. Okay, never. Because surface tension is the force acting per unit length. Surface energy, same force into displacement. So it will be equal to surface tension into area. Correct? Surface tension into area, we wrote same stuff here. But while you are expanding, both inside and outside surface is acting. So you always consider two surface. Note it down, very important. I will see in your notes. Did you mention a very important in this? You will consider two surface. If you are considering two surface in this situation, what will be your surface energy? Surface tension multiply by the area, and you are considering two surface. That's why multiply with 2. Correct? What is normal energy? Force into displacement. Force into displacement. So what will happen? This dd will be cancelled, and your surface tension will be equal to force acting on the length. But both the surface, that's why 2. And trust me, you will never have issue. Again and again, I'm telling you, in the formula you will have issue in this 2 number.
So can you actually explain the two surface part again? So I'm a little bit confused.
Because when you are applying any force, or like water is applying any force, it is applying on the outer surface as well as inner surface. So two force are acting in this case on two length. So your net force will split into F by 2 in each part. If you consider two surface, outer and inner, two surface outer and inner. So in this two surface outer and inner, in this two surface total force is F. So for each surface your force will be F by 2. Make sense? So what is the tension? Force per unit length. What is the actual force acting on each layer? F by 2. Understood, Jordan?
Yes, sir, understood.
Tell me, Jordan, what is the impact of temperature on viscosity?
So I mean, if you think about it, temperature increases, kinetic energy of particles increase, therefore viscosity increases.
Decrease.
Decrease. So,
Because
can you
what is the
explain?
viscosity? Viscosity is basically
Or
how
friction between outer and inner.
friction between the layer will reduce. Correct? If you
Huh.
increase the temperature, then friction usually reduce. It means viscosity will also reduce. Same way, surface tension between the particle will also reduce. Why? Initially, particles were attracting each other a lot. That was surface tension. When you increase temperature, this attraction will reduce. It means surface tension will reduce. Tell me, any doubt? Temperature increase, friction decrease, so viscosity decrease, and here surface tension decrease. Any doubt? Anybody have doubt in this?
No,
See
sir.
how
No, sir.
surface tension and viscosity is decreasing with the increase in temperature. Angle of contact. Angle of contact means what is the relation of the tangent of the liquid surface at a given point at a given contact and the solid surface inside the liquid will be considered as the angle of contact. You will not understand what I said if I don't draw diagram. Example, this is the surface. Okay. And this is the liquid drop. In this case, there are three things: solid surface, liquid surface, and air. Correct? Here you will have surface tension. Here you will have surface tension between the solid and liquid surface. Make sense? Here outside, not inside, outside, you have surface tension between the solid surface and air gas. Correct? And this one is the tangent drawn. This is what we are talking about. This is the surface tension between the liquid and air. And this angle we are talking about, this theta is the angle of contact. So it is the angle between the tangent to the liquid surface at the point of contact. So this is the point of contact. You have drawn this tangent. This part is the tangent drawn, and here it is solid part inside the liquid. So angle between the tangent and the solid surface will be known as the angle of contact. Understood? This is angle of contact theta. Any doubt, guys? Angle, understanding where you have this angle is extremely important because you can make mistake here. I know where you can make mistake. According to that, I am highlighting the keyword. Got it? Anybody have doubt what is the angle of contact? Because if you know the angle of contact, then things become easy. Any doubt, guys? If no, I will make another.
So if it's like an acute angle, then it's considered as wetting, no, sir.
How wetting happen, we will explain in this diagram only. See, there are two things.
Okay, sir.
If it surface is like this, then how you will explain the angle? First, you have to draw tangent. Tangent from this is still this. Okay. And here, liquid present with the solid surface. Liquid present with the solid surface. Then this will be the angle. In both the situation, you have angle of contact only. Got it? In both the situation, you have angle of contact only. Anybody have doubt, guys? So how to define this angle of contact? It is between the tangent to the liquid surface, between tangent to liquid surface, one thing, and solid surface inside the liquid. So I will draw this again to make you more clear. This is the solid surface present inside the liquid. Correct, guys? This is the solid surface present inside the liquid, and this is the tangent drawn on the liquid. Angle between these two is angle of contact. Second, this is the solid surface present inside the liquid. I have to change the color, slightly increase the size. This is the solid surface present inside the liquid. At the same time, this is the tangent drawn on the liquid. Angle between them is angle of contact. So it's important to understand where we are making angle. One at tangent and second solid surface present inside the liquid. Got it? Trust me, 90% people make mistake. Where is the angle of contact? Whether it will wet the surface, do not wet the surface, all depend upon this situation only. What is the angle of contact? Tell me, anybody have doubt between these two diagrams? In both situations, theta is explaining your angle of contact. Okay. And based on this, you will understand how water behave in different situations. Example, water form droplet. हेलो प्रतिज्ञा, क्लास अभी तो मैं क्लास ले रहा हूँ, ये क्लास कंप्लीट करूंगा. हाँ, वाह जी वाह, बैंक गई थी, बैंक बंद है, क्लास भी खराब हो गई. हाँ हाँ, अब घर आ गई, फिर ज्वाइन करो क्लास. ठीक है, ज्वाइन करो. हाँ. Okay, so guys, water form droplet on the lotus leaf, but same water spread over the clean plastic plate. What is the reason? Angle of contact will explain. Okay, angle of contact will explain all these things. Example, when you see water form droplet in case of lotus leaf, you will see कि this angle of contact is obtuse. Correct? But if you see in case of plastic, when it's spread, then theta will be acute. Any doubt, guys? Jordan, your question.
Yes, sir. So if the theta is obtuse, like greater than 90, then it will not wet the surface.
Yes.
But if it's acute, it will wet. So my question is, when it's 90 degrees, where does it fall under?
As of now, we are talking about, we will discuss about the 90-degree as well.
Oh,
But
okay, so then later I'll ask.
In this situation, you can easily see if angle is more than 90 degree, then liquid will not wet the surface. Example in this, when water form droplet, do not wet the surface. Correct. And if theta is acute, then it wet the surface. Okay, got it? Anybody have doubt? He wet the surface as you can see in this diagram because your water spread over the surface, so it will wet the surface. And in this case, you can see in the diagram angle is less than 90 degree. Correct? So it will spread. That's why wet the surface. But in this diagram, water will form a round droplet. It is not properly even touching the surface. I messed it up, but actually there is very point that touch the surface. So it will form the round droplet. So angle in this case is obtuse angle more than 90 degree. Correct? And as you can see, it is not touching much of the solid surface part. It will not wet the surface. Any doubt, guys? And you know this kind of question already asked in NEET. Make sense?
Yes, sir.
Okay. So these are the things extremely important for your exam. Ki if theta is acute less than 90 degree, it will wet. And if theta is obtuse more than 90 degree, do not wet. So here theta acute means less than 90. Here theta obtuse means more than 90. Chandana, tell me why drops or bubble usually are spherical
So water droplets.
and bubble why they try to become the spherical surface.
So is it due to surface tension?
Yes, it is. If you see, you take any droplet and bubble, they are spherical in nature, spherical surface. Why? Your answer will be because they want to acquire the minimum energy. Want to acquire minimum energy. And when there is the minimum energy in this case, it will have the least area surface tension, and least area is more stable. Any spherical body will be more stable structure. Any doubt, guys?
So 1 second, can you scroll up? Yes, nothing. I didn't miss anything. I just wanted to check if I missed something.
Hmm. Any doubt? Any doubt, guys?
No, sir, just one copy here.
Hmm. I think we will take maximum 10 more minutes to finish everything. Till then, I can make a call. हेलो। हाँ जी भाई साहब, मैं डॉक्टर दीपक बोल रहा था, जो आपने कल बात हुई थी गाड़ी दल, तो आज अवेलेबल है क्या गाड़ी इस टाइम? हाँ अभी नहीं, मैं कल कहूँ तो था, हाँ ठीक है, 1200 में डन है। अच्छा, उसका कि मेरे पे गलती रह गई, ओके, सॉरी फॉर दैट। तो आज देखो, ये बताओ है कि नहीं इस टाइम? हाँ हाँ। कदोड़ मतलब अपना काम में गाड़ी तो जाना है। ठीक है, मैं और धर्मवीर लेकर जावांगे, धर्मवीर ना जाने दोगे? हाँ, धर्मवीर वो चलाओगा। हाँ समझ गया। ठीक है। हाँ बिल्कुल, अपने में तो पड़ा घंटा पर में। हम्म। ठीक है, मैं, आप पूरी दुकान में को नहीं हो गए? तो दुकान मतलब कोई और ओपन करे आज? ठीक है, मैं दुकानदार जाकर एक बार फोन करूँ आपको तो। ठीक है, धन्यवाद। डन गाइस, एनीबडी
Done, sir.
लेफ्ट एनीथिंग? चलना फिर? हैं? हाँ हाँ, गाड़ी तैयार है। बस करने को निकलना उड़े आज घर। चलना फिर उड़े। ना 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 ना, बाहर को नहीं करता, कथरों में को जावांगे फिर। हाँ फिर मैं आऊँ, 10 मिनट दे, 10 मिनट तक। फिर ज्यादा तो इतना उड़ा आ जाए तो 10 मिनट हो जाएंगे थोड़ा। सो गाइज, here we gonna talk about very important topic that asked in NEET very frequently: axis pressure. अरे, axis pressure. So what happen when you want to calculate axis pressure? The simplest way to calculate axis pressure, you know, work done is equal to pressure into change in volume. Correct, guys? If you know you have a droplet and inside you have more pressure compared to outside, so what will be the work done due to this pressure? Internal pressure should be high, only then it will expand, minus outside pressure. Pressure into volume. What is the change in volume? It can be area into change in length. Area for the spherical surface is 4 pi r square and delta r. Make sense? And what is your work done? Work done is, I will write separately first. Work done is equal to force into displacement. Correct? It will be force into displacement, or force is equal to surface tension into the length into displacement area. So can we say surface energy is equal to tension multiplied by area? You already did this. Yes or no?
Yes, sir.
Any doubt in this case? So this work done will be equal to tension into area. And it will be taken double. It will be taken double. So this is area, this is also area. You can cancel it out. If you calculate the difference in the pressure, it will be 2 into surface tension divided by total length increase will be r. That's done. Is it messed up or you understood this? 2t same, delta r integration, r will go to another side, and this is the axis pressure. I wrote this again from the last topic for the repetition for revision. Got it? This is in case of water droplet. In case of droplet. Aja, if you consider the bubble, the thing what we consider in bubble is you consider two interface here. Instead of one, you consider two interface here. And that's why axis pressure will be equal to 4T by R. In case of like soap bubble. Done, guys? And if you
1 minute,
look at
sir.
this, you will have this kind of thing also. Circular disc, radius this, surface tension this, axis force. Axis force means you can correlate with the axis pressure. Energy required for the soap bubble. Soap bubble, whatever you calculate for the water, you will multiply with 2. If soap bubble expand, pressure inside the bubble, pressure will always more, only then it can expand, right? Right? Only then it can expand. So bubble, you are calculating excess pressure here in 23rd question. So most of the question is related to this axis pressure. One last topic is left capillary tube, like 22nd, 22nd, and 22nd question, like capillary tube. Capillary tube topic is really important because you will see few question, and wettability of the surface depend upon the primarily what angle of the contact. See that question 27th. Wettability, whether a surface will be wet by the liquid or not, it depend upon the angle of contact. Done. Correct. So a small topic is left, that is capillary. It will take only 5 minutes, but I have to leave for some work very urgently. So I'll stop the class right here. Just 5 minutes. Only one formula, capillary, but I'm in hurry. So
So
I'll
can you just
finish
show
in
the
the.
screen then, sir? Like
I
the
will share
notes, or
both
can
the
you
notes.
share it?
I will share the notes.
So when is the next class?
I will consider at 8 p.m. Considering the all the factor. I have
So when
to
can you speak
distribute
to my father?
during the journey only. Now
You'll
only
do
after
it,
this
no?
class.
Okay,
Yeah.
sir.
So I have to distribute the wedding card. In relative, it is extremely important. Otherwise, they feel no.
I know the drama and all happens.
Exactly.
Yes, sir.
That's the
Sir,
stuff.
can you tell us what the task is?
Yes.
Yes, sir.
So
So tomorrow me and Jordan have exam also.
Yeah, so that's why I asked you to speak to parents because I'm so scared.
no, for this
So
I'll talk
human
to.
reproduction is coming. Human reproduction and biotechnology one.
And reproductive health.
Yeah, reproductive health. Like both reproduction chapters and biotechnology one. So
So biotechnology complete chapter na.
yes, sir.
Yes, sir.
So now time is 11:30. I am considering class at 8 o'clock. So you still have 8.5 hours.
Yes, sir.
So all of you will finish full biotechnology chapter,
Yes, sir.
not because you have an exam, but this is extremely important chapter.
Yes, sir.
Okay,
So can you send
biotech.
questions also?
Yes, I will send right now.
So,
Otherwise, I'll forget.
yesterday I did reproductive health. Can you check later? Like I sent notes also.
In the group.
Yeah, yeah. After doing, like, after completing the video, that fluids one, I did reproductive health at night.
Okay, very good. So yeah, sure. Biotechnology and process.
Also, sir, I wasn't feeling well right now, so I didn't write the notes, but I'll write it now and send, like, I'll in some time. I'll start writing and then send it.
Okay, that's fine. But you have to send as soon as possible.
Yeah, yeah, sir. I'll send before 2 o'clock.
Before 2 o'clock.
Yeah, or maybe
Okay.
1:30.
Okay. So all of you send notes in the group. I'll check. Finish the biotechnology chapter and 20 question from this BA. 20 question from this is the first priority. Second is biotechnology. Because we
You
already
upload
covered
the
chapter
video in
except
YouTube.
yeah, I'll upload video in YouTube very soon. The moment I get this, I will upload YouTube video.